Welcome back, everyone. I hope you enjoyed the WIS Maastricht conference video series. So today, this video is about a talk from Anna Wilbik. So Anna is a professor in data fusion and intelligence interaction at Department of Data Science and Knowledge Engineering at Maastricht University. So her talk gave a very interesting angle to think about responsibility, explainability, and understandability in the artificial intelligence and data science domain. So if you want to hear the opinions from Anna, please keep watching this video.
So the next talk will be by Professor Dr. Anna Wilbik. She is a professor in data fusion and intelligent interaction at the Department of Data Science and Knowledge Engineering, which is part of Maastricht University. She received her PhD with honors in computer science from the Systems Research Institute, Polish Academy of Science in Warsaw in Poland in 2010. And in 2011, she was a postdoctoral fellow with the Department of Electrical and Computer Engineering, the University of Missouri, Columbia in the US. Anna is alumnus of Stanford University Top 500 Innovators, so the Science Management and Commercialization Program. And from 2013 till 2020, she was an assistant professor in the Information System Group of the Department of Industrial Engineering and Innovation Sciences at Eindhoven University. And today she will give a talk about does explainability imply shifted responsibility? So now I can give the floor to you.
Thank you. But before we start the talk, I would like to hear your opinion. So imagine a situation where you have farmers cooperation and they install smart pigsty solution on their farms or on the farms of their members, and they promise the costs will decrease and quality of the meat produced will increase. However, we have one farmer where things go wrong. His energy bill is 20% higher. And then the question is, who is responsible? So now you can see the pool in Slido. So please go to the Slido and see the pool there. And I would like to ask you, so who is responsible in this case? Is it the system developers? Is it the system? Is it farmers' cooperation? Or is it the farmer? We don't know who, what went wrong. The system is a black box. So who you think is responsible? Who should pay the increase of the energy bill? So I see some answers coming here. So there are some discussion. Sometimes it is system. Most of you think it's system designer or it's system, farmers cooperation. Farmer is not to blame. Then imagine the next case. The same farmers cooperation installs a smart system solution, and again the costs go up. But now the system explains its decision about climate control. So, for instance, that the heat is, the styes are heated more in the morning because ventilation is also higher. So energy cost goes up and animal health goes worse. So who is to blame? Is it the system designer, farmers' cooperation, or the farmer? So in this case, I see that most of you, they decided that farmer is to blame, and it's less fault of farmers' cooperation or the system. Usually, when we are thinking about responsibility, we should consider situations when things go wrong, because then we want to find who can we blame for the situation. And this is not only about farming, this is not only about pigsties, smart house, but there are more cases, similar cases. For instance, mortgage processing systems makes mistakes and evaluates wrongly the risk, and people miss their house of dreams. Or in a banking environment, black box neural networks makes a bad decision and invests money badly so that company loses all its assets. Or an AI systems advises a doctor to take the surgery for a patient and patient doesn't survive this surgery. Or if we have autonomous traffic management systems that controls the lights on the crossing, there is some mistake and there is an incident. So there are many examples that you can find where things may go wrong. And when we are talking about responsibility, we can talk about a responsibility quadrangle. On one end, we have a system designer, so people who developed the system. We can talk about the system itself. Currently, according to the Dutch law, system is not legal entity, so it cannot be blamed. But when we are talking casually, we can say, oh, it's the system that make a mistake. So it is more about the feeling. There are the users. So for instance, in this case, it can be the farmers' cooperation or a bank. And we have also subject of decision. So for a banking case, it may be a client who is applying for a mortgage, and then the decision is whether he or she will receive this mortgage. And there are two sides, two forces here in this triangle, in this quadrangle, namely technology push. So the technology makes certain decisions, certain limitations, but also there is requirements push. So the system users want to have the system that fulfills certain needs. And when we are talking about understandability, we should think that there are different notions or different flavors to it. So we can talk about explainability, when the system explains the decisions that are made. Usually those explanations are ad hoc or post factum explanations. There is also interpretability, when you can interpret the results that the system has created. And there is also transparency. And transparency is that the system shows how a decision could be has been achieved in a more transparent way. So those three terms, they come close, but each of them, they mean something different. So this is quite important to know which aspect of understandability we are talking about. And when we are talking about the data, first we see that dashboards are getting more and more popular. Well, we could see this in the corona case. Every country has produced its own dashboard to inform people about the number of new infections, deaths, hospitalizations, and so on. But dashboards are also used in industry. So here is a dashboard that was produced in a project that I was working on. The project involved building a smart or involves smart pigsty system, because the project is still not finished. And first, the company installed the sensors, the climate sensors in pigsties, and then they visualized those data. So we can see that the farmer can see CO2 level, temperature inside and outside the barn, the humidity, but also the plots. So different plots. But there was a big but. Most farmers didn't like it. Why? Because to understand plots, you need to have certain skills. For instance, to understand this plot, you need literacy skill level 3. And so this plot shows numerical literacy levels divided by different countries. And 60% of the people, they don't have the proper skills to understand a plot dashboard like this. Meaning that dashboards are nice, but only for trained people who know how to read them. But for most of the people, they are too difficult. So what can we do next? Well, there is a well-known saying that a picture is worth 1,000 of words, but I think we should add verbalizations or text words to the pictures to provide the implementation. On one of my previous phones, it was a Samsung phone. I noticed there was a Samsung Health app. Well, we all want to be healthy, move more, and so on. So I experimented with this app, and then what I noticed that the phone was measuring the step counts, and then was also providing visualizations of where I was, and a short verbalization showed a short description what is coming, what is important, how to read this figure. And in my work, I am working for a long time on linguistic summarization. So linguistic summarization is a technique that allows to understand the data, the numerical data, by capturing the essence of it and presenting the essence in terms of natural language. It is a simple template-based approach. For instance, in this case, we could have summaries like most pigs are healthy or most young pigs are healthy. This approach is based on fuzzy logic. I'm not sure whether you're familiar with fuzzy logic or fuzzy sets. So when we are talking about classical sets, an element belongs either to a set or doesn't belong to a set. So the characteristic function can have only two values, either a 0 or 1. In fuzzy sets, everything is a matter to a degree. So when we are talking about the characteristic function, then the values obtained is the degree to which element belongs to a set, so-called membership value. And it is from the interval between 0 and 1. If we know that the membership value is equal to 0, then the element doesn't belong to a set. If it is equal to 1, it belongs 100% to the set. But it also allows all the stages in between. So an element can belong to a degree to a set. And this property can be used to model the natural language that we are using to express certain values. So for instance, we can say that a day is nice, temperature is hot. So how it could work in a linguistic summary? So we have a template, Q, R, Y, RP, where Q is the quantity, so quantifier, R and P's are our linguistic labels, and Y is the object. In our case, those are the piques. And then we can say that piques, they have certain features like age, type, fit, characteristics, activity level. And then for the age, we can have young, middle age, and old. And from the data, we can calculate, generate the summaries, and calculate the degree of truth of such summaries automatically. And then we applied this to the dashboard that you have seen this again, and we created the summaries. So, for instance, for the temperature, certain number of differences in temperature during the day were slightly high, or few of CO2 values were too high. But we noticed, we interviewed the farmers, what kind of summaries, what kind of information you want to see. And they wanted to see information where the things were not going in the right direction. They wanted to be warned about situation. Therefore, if in some cases everything was going fine, the farmers had seen no summary. And this is the case of humidity, so the lowest box where nothing was presented. We evaluated this solution using technology acceptance models. We interviewed farmers who used this system for at least 2 weeks, and we noticed that this solution, so verbalization, they liked it. They find it easy to use and more informative than the dashboard, than the visualizations. They still had access to the visualizations, but only if they wanted. So, to conclude, now we have the situation that a farmer uses a linguistic summarization system and all animals got sick. Who is the blame? Is it the agro-food developer, so the consultancy company that developed the system? Is it the system itself? Is it the farmer? Or are those the pigs who are the subject of the decision? I see that most of you, they have found the farmer responsible for the animals' health, although there are some votes about the system and the consultancy company. My take on this is that by giving the explanations, by providing understandability to the system user, we can make him more responsible for the decisions that he's making. We can empower him that he understands how the system can support him and make better decisions. Thank you for your attention.
Thank you very much indeed, Anna. But there is one question here. I'm going to try to sum it up a little bit. Egon is asking, should the question not be who took the action that ultimately caused the outcome, or should it not be to the farmer to decide to turn on some system? So,
well,
yeah.
This is currently the case. For instance, in banking, if you donate your money to bank to invest in some investment funds, you take the responsibility that the bank might actually lose your money. So, but when we are talking about AI system, sometimes we do, and especially if the system is a black box, we just don't want to accept our responsibility because we don't know what is happening. We have made the decision, okay, we trust the system, but was the decision the right one? It's a different story.
Thank you. Thank you very much indeed.
If you like this video, please subscribe our channel.